So now our job is to use our new skills to combine resistors in parallel to solve more complicated problems. You can see here that I've given you an example of a circuit in which there are two 6-ohm resistors in parallel with one another. We can see that by tracing the tops and bottoms. And I could calculate, for example, the equivalent resistance, R equivalent, and because there are only two resistors involved, I can do the product, 6 times 6 divided by the sum, 6 plus 6. That'll be 36 divided by 12, which is 3 ohms. And here's a real nice shortcut. Anytime you have two identical resistors in parallel, their parallel combination will be 1/2 of the original resistance. So you can see 6 in parallel with 6 gives 3 ohms. So I'm going to redraw this circuit now. I'm going to have the 12-volt source, and it's going to come down here, and it's going to go just through a single resistor, which is 3 ohms. And so here's 12 volts. And notice that the current I is in the undisturbed portion of the circuit. So I have the current I right there. And gosh, at this point, we've reduced the circuit down to the point where it's just an application of Ohm's law. So I is going to be equal to V divided by R, which is 12 volts divided by 3 ohms, which is 4 amps. So we reduced the circuit by combining the two resistors in parallel, and then we were able to use the reduced circuit, the simplified circuit, to solve for the unknown current. Here's another example where we have 3 resistors in parallel. You can see that they're in parallel because we can easily trace both sides of each pair of resistors, passing only through wires and junction points. So I can calculate the equivalent resistance, R equivalent. And because there are now 3 resistors, I can't use my shortcut. I'm going to have to say it is equal to 1 divided by 1/5 plus 1/5 plus 1/5, which it turns out is 5/3 or 1.667 ohms. Good shortcut. If you're combining 3 identical resistors in parallel, the result will always be 1/3 of the original value. So you can see 5 ohms became 5/3 or 1.667 ohms. So therefore, I'm going to go ahead and show the reduced circuit. .667 ohms goes there. 12 volts goes here. The current we're looking for is I, and it was undisturbed, so we can leave it right where it was. And then I is equal to 12 volts divided by 1.667 ohms, and that works out to be 7.2 amps. So combine 2 resistors in parallel, combine 3 resistors in parallel. In either case, we get down to a circuit where we can just simply apply Ohm's law. Third example for today, we have 3 resistors in parallel. They're all identical 3 ohm resistors. So I could jump straight ahead to the fact that it'll be 1/3 as much, but let me go ahead and prove that to you. So R equivalent is equal to 1 divided by 1/3 plus 1/3 plus 1/3, and sure enough, that does work out to be 1 ohm. I can redraw the circuit, and now this is a current source. So I have 2 amps. This is all going through a 1 ohm resistor, and the voltage that I'm looking for is right there. So the final solution in this case, V is equal to I times R. This will be 2 amps multiplied by 1 ohm, which will turn out to be 2 volts.